Dear students, welcome back to Matrix with DJ. So last video we discussed how we can check whether a relation is reflexive, symmetric and transitive. Reflexive condition is every element in a set is related to itself. Then we can say that the relation is reflexive. Symmetric means if AB belongs to R, then the element BA also should be belongs to R. And the transitive condition is if AB belongs to R and AB and BC belongs to R, then AC also belongs to R. If a relation is reflexive, symmetric and transitive, such kind of relation we can call as equivalence relation. So today we can discuss some example questions from NCERT. Already I have given a question for your trial in last video. I hope you have tried it. So next example is, let T be the set of all triangles in a plane. So here the set given is, A is set of all triangles. Set of all triangles in a plane with R a relation in T given by R is T1, T2. So R also, the relation also you have to write down. T1 comma T2 such that T1 is congruent to T2. This is the relation. Show that R is an equivalence relation. If a relation is equivalence, it should satisfy the conditions of reflexive, symmetric and transitive. So first we can check one by one. First we can check reflexive condition. Reflexive. So for checking reflexive, first you have to write the condition. Always constructive steps you have to write. So if AA belongs to R for every A belongs to A, the set. Okay, dears? So here let T1 comma T1 belongs to R. If T1 belongs to R means what we can say? T1 is congruent to T1. Every triangle is congruent to itself. So that we can say R is reflexive. Since every triangle is congruent to itself. Therefore, we can write R is reflexive. I hope you understood this, right? To check the condition of reflexive. Now we can check the condition of symmetric. So what is the condition of symmetric, dears? Yes, if ordered pair A comma B belongs to R, which implies when we switch the order, that means a BA also should be belongs to R. This all A, B, these all A comma B, all kind of A and B belongs to the set. So each element we are taking from the set itself. So now we have to check whether it is symmetric or not. So here we have to consider let ordered pair T1 comma T2 belongs to R. If T1 comma T2 belongs to R, then we can say that this triangles T1 is congruent to T2. If the first triangle is congruent to second triangle, means second triangle also congruent to first triangle, we can say that, which implies T2 comma T1 also belongs to the relation. Therefore, we can say that R is symmetric relation. Next, we have to check transitive. So what is the condition of transitive, dears? You know that if A comma B and B comma C belongs to R, which implies A comma C belongs to R. For every A, B, C belongs to the set A. Okay, dears, always you have to write the condition. Thereafter, you can write, we have to consider two pairs. So let T1 comma T2, and starting from T2 you have to consider another one. T2, T3 belongs to R. If T1, T2 belongs to R, we can say that T1 is congruent to the triangle T2, and T2, T3 belongs to R means T2 congruent to T3. If first triangle is congruent to second triangle and second triangle is congruent to third triangle, then obviously we can say that T1 is congruent to T3, we can say. Therefore, what we can say, R is symmetric. Okay, dears? So each condition we have to check. I hope it's clear. So since this relation is reflexive, symmetric, and here it is transitive. Here this case is transitive. Okay, it is transitive. R is transitive. Transitive. So that we can write it is R is equivalence relation. So R is reflexive, symmetric, and transitive. Therefore, we can say that R is an equivalence relation. I hope it's clear. Then we can check example 3. Let L be the set of all lines in a plane and R be the relation in L defined as L1, L2 such that L1 is perpendicular to L2. Show that R is symmetric but neither reflexive nor transitive. So R is not reflexive. What is the reason R is not reflexive? So here L is set of all lines in a plane and the relation R is the line perpendicular to each other. So reflexive. First you have to write the condition of reflexive, and you know that if L1 is perpendicular, if we consider L1 and L1, if L1 belongs to R, okay, if L1 belongs to R, then we have to say L1 perpendicular to L1. Is this correct? It is false. No line is perpendicular to itself. So the statement is false. Therefore, R is not reflexive. Now we have to check the condition of symmetric. Is it symmetric? You have to check. If L1 comma L2, first you have to write the condition, dears. Condition you have to write. Then L1, L2 belongs to R. If L1, L2 belongs to R, we can say that L1 is perpendicular to L2. If L1 is perpendicular to L2, we can say that L2 also perpendicular to L1. Therefore, we can say L1, L2 belongs to R, which implies L2 comma L1 also belongs to R. Okay, so we can say that L1, L2 comma L1 also belongs to R. Therefore, we can say that R is symmetric. Now we have to check transitive. Next, we have to check the relation is transitive or not. transitive relation. So for that, we need to consider two pairs. If L1 comma L2, which is already belongs to R, and L2 comma L3 belongs to R. So if L1, L2 belongs to R, we can say L1 perpendicular to L2. And L2, L3 belongs to R means L2 perpendicular to L3. So here we can check with some lines. So L1 is, the line L1 is perpendicular to the line L2. And the line L2 is perpendicular to L3. So it means that L1, L3 is perpendicular? No. So, but we cannot say that L1 is perpendicular to L3. That means we have to say that L1 is not perpendicular to L3. We can say L1 is not perpendicular to L3. So here we have to say this. Sorry, dears. So here we have to write L1 is not perpendicular. Yes. So L1 is not perpendicular to L3. Therefore, R is not reflexive. Okay, dears? This is the condition. Next example. Show that the relation R in the set 1, 2, 3 given by R equals set of ordered pair 1, 1, 2, 2, 3, 3, 1, 2, 2, 3. We need to check is, need to prove that. Here it is proving question. So we need to prove that it is reflexive but neither symmetric nor transitive. So reflexive case, we need to check 1, 1. Every element should be related to itself from the set A. So 1, 2, 3. A is the set A is 1, 2, and 3. So for reflexive, we have to check 1, 1, 2, 2, 3, 3. Yes, 1, 1, 2, 2, and 3, 3 belongs to R. Therefore, we can say that R is reflexive. So that is finished. Then symmetric, we have to check. Symmetric. Here, 1, 2 is there, but 2, 1 doesn't, right? So here, 1, 2 belongs to R, but 2, 1 doesn't belongs to R. If any one element is not satisfying the condition, then we can completely say that R is not reflexive. Okay. So that we can say that R is, sorry dears, R is, which implies R is not symmetric. Then we have to check transitive condition. Transitive, for transitive also we have to check like this. So 1, 2 and 2, 3. For transitive case, we can consider transitive case, we can consider 1, 2 and 2, 3. We have to select the elements like 1, 2 start from 2. Starts from 2, 2, 3. Belongs to R. And you have to check, is 1, 3 belongs to R? No, doesn't belongs to R. Therefore, what we can say, R is not transitive. Okay, that's the thing. I hope it's clear. Okay, next it is the fifth example from the textbook. Show that the relation R in the set Z, means set of integers, given by R equal to ordered pair A, B such that 2 divides A difference B is an equivalence relation. So reflexive means we need to check first reflexive. So first you have to write the condition. Before that we can just rearrange this one. So ordered pair AB such that, that means the ordered pair AB such that A difference B means 2 divides A difference B. That means A difference B should be multiple of 2. That's the meaning. Okay, dears. It should be multiple of 2. If it is multiple of 2, obviously it can be divisible by, it can be divided by 2, completely divisible by 2. Then we need to check if AA belongs to R. If AA belongs to R means you know that A difference A is 0 is multiple of 2 only, right? Or is divisible by 2, right? Or 2 divides, yes. So we can write divisible by 2. Okay. Then therefore we can say that R is reflexive. Now we have to check symmetric. So for symmetric, we have to check if A comma B belongs to R. If A comma B belongs to R means A minus B is multiple of 2. If A minus B is multiple of 2, obviously you can write B minus A also will be multiple of 2. Right? Yes. Therefore, what we can say, which implies 2 divides B minus A also, right? Divides B minus A. Therefore, we can say that R is symmetric. I hope it's clear. We have to select a pair from the relation, and you have to check when we switch the order, then also belongs to R. Then we can say that R is symmetric. Next is transitive. We have to check transitive condition. So for checking transitive, we have to consider if A comma B and B comma C belongs to R. So if A comma B belongs to R, then we can say that A minus B is multiple of 2, or 2 divides A minus B, right? And BC belongs to R, that means we can say that B minus C also multiple of 2, or 2 divides B minus. Then if we add two numbers which is multiple of 2, then also it is, for example, 4 is multiple of 2 and 6 is also multiple of 2. When we add 4 plus 6, that is 10, that is also multiple of 2, right? So when we add two numbers which is multiple of 2, the result also remains the same. So that we can write A minus B plus B minus C also multiple of 2 is multiple of 2. Okay, dears. Therefore, what we can say, B will be cancelled. So you can write that A minus C is multiple of 2. Or we can say that 2 divides A minus C. We need only to get the relation between A and C. That's what we have added. So for this purpose, you need to check how we can get the relation between A and C from the previous step, this step. Okay, these steps. So here we can say therefore R is transitive. Since this relation is reflexive, symmetric and transitive, therefore it is an equivalence relation. I hope it's clear. Now your turn. Please try to solve this question, and if you have any further doubt, comment below. And this answer also you can comment below. Thank you. We can see you in next video.